This is going to be a quicker example of solving right triangles, and of course remember we mean finding all side lengths and all angle measurements when we talk about solving any triangle. But in this case we have a right triangle ABC, and we've been given a couple of side lengths here. We know that A is 2.73 meters and B is 3.41 meters. We want to find the remaining sides and angles. So just like we have in the past, the first thing we want to do is we want to start by kind of sketching the image of the situation here in the first place. And we have triangle ABC. We weren't given any of the angles, so I kind of have leeway to put the angles where I like them. So I kind of like having A and B as being the acute angles, and we have capital C as being the 90-degree angle. Furthermore, we know that lowercase c is opposite upper C, lower a opposite upper A, and lower b opposite lower b, or upper b. But we've also been told this. We know that lower a is 2.73 centimeters, so 2.73 meters, sorry, and then we know that b is 3.41 meters. Okay, so just like in the last video, we're going to kind of, and we know that c is 90 degrees. We're going to kind of start by saying, well, you know, considering this, what would be an easy thing to solve for and how could we find it? Well, I think in this instance, it's harder to find the two other angles because of the fact that we only know one angle. So even though I know that all of them add up to 180, knowing only one of them doesn't help me find the other two right off the bat. Okay, the best I could do for you is that say angles A and B have to add up to 90. They have to be complementary. And I can also find side length C. Okay, so in terms of writing down what we know, well, I suppose we could put 2.73 meters over here on our triangle, and we know that this is 3.41 meters over here on our triangle. So we say, well, how could we solve for C? One way to actually do this here is to use the Pythagorean theorem. Since it's a right triangle, we have two side lengths. We can actually go ahead and put in our values here for what we know and solve for what we don't know. So this is 3.41. We could grab a calculator to help us with these calculations here. So for instance, we could say 2.73 squared, okay? And I'll add that to the memory here. We say 3.41. What if I squared it and I add back what I had in my memory here? So the left side of this equation is 19.081, and this is equal to c squared. But what we want is actually just c. So now, without rounding yet, we're going to take the square root of this number, square root, and we get about 4.368. So c is about 4.368, and we want to make sure we label this. This was in meters. Okay. So the next thing I'm going to do is I'm going to go place this on the picture. We have 4.368 meters. This is 4.368 meters. Okay, so now we know all three side lengths, and it seems to me that this is reasonable, seeing as how that was opposite the largest angle. It must have been the longest side, and it looks like the longest side. So now the question becomes, how do we solve for these angles? And again, we can use SOHCAHTOA to do this. We could have used SOHCAHTOA just then to find the measure of length C. But let's go ahead and start with this. We say SOHCAHTOA-wise, let's say I want to find angle A. And so what we're going to do is we're going to take this angle A, which is unknown, and we're going to relate it to a couple of knowns. And it looks like we have a couple of knowns on our triangle. We have a few. We know this, we know this, and we know this. So perhaps how could I relate angle A to maybe this side opposite and this side adjacent? And going back to SOHCAHTOA, we say we could use tangent. Tangent is opposite over adjacent. So writing this out, here's what I would expect to see on a paper. We say the tangent of the angle. Now the angle in this case we don't know. So we'll call it tangent of angle A. But we know that the tangent of angle A equals 2.73 over 3.41. And so this equation happens to be valid. We say this is the angle A that is so big that if you took the opposite side and divided by the adjacent side, you'd get this ratio right here. Our job is going to be to do this. We want to take this and get the tangent out of the way and get A back by itself. So we could, you know, we get a calculator at 2.73 divided by 3.41. We'd get this about 0.8006 on the right side here, 0.8006. But we can undo this tangent, and the way we'll do this is the way we've done in the past. We'll use the tangent inverse key on our calculators. So what you do to the left, you have to do to the right. These cancel out. We get left with this. The angle A is equal to the tangent inverse of this 0.8006-ish. Okay, and we can grab a calculator and ask it this. The nice thing about this is if we were to take the tangent inverse of this, we have to hit shift here, tangent inverse. It says you have about a 38.7 degree angle, and it is the general convention that we'll go out to the nearest tenth on our angle. So 38.7 degrees. We're going to go put that up here for A, 38.7 degrees. The nice thing about this is that we know that 38.7 degrees, if we also put it here, it has to be complementary with this angle up here. So now the question becomes 38.7 plus angle B, that has to come out to be 90 degrees, then what is our angle B? And of course what we'll do is we'll just take 90 and take 38.7 off of that. We could even take 90 off of this number and just make it positive again. We say it'd be about a 51.3. So B is about a 51.3 degree angle. We should go put that in. We say this is a 51.3 degree angle and this is 51.3, and it seems that our answers all look reasonable. Cheers.